it's always very difficult to follow an act like Wayne. So I got a few problems. First of all, he took all my time. It's a tough act to follow, and I feel like I've been through some chemotherapy here. But typically, it's great to typically Wayne. Thank you for Wayne for that history. You're thinking back about Gèrard and the time that we were there at the laser lab starting. We started at the Institute of Optics. It was such a unique time. It was such a unique time because everybody was new. Gèrard was new there. The laser lab was new. We were new. And so when things are all new, there's all kinds of opportunity. So it was not difficult to do something new in that time. And the message that I've kind of been left with is that to be involved with Gèrard, and as you've said, he's a visionary, and that was really the case. But it was always about breaking barriers, doing something just more, going through the next barrier and the next barrier. This is what drove Gèrard, and he instilled that in all of us. First of all, we never should have been in the laser bay. This was a clean room. And that was the first barrier we broke, is Earl figured out how to climb in under the stairs, take out a couple of steps, and climb into the laser bay, and there we were. We had broken our first barrier, and we had to hold on to the pictures for about 20 years for the statute of limitations to run out on us. But here we were. 1980 was the beginning for us, and this was a momentous event, that the United States and the world felt with Mount St. Helens blowing its top there. But for us, it was a change of similar magnitude in our careers. It would change us kind of forever. And as we were students at the Institute of Optics, my advisor was Conger Gable, as was Jim's. And we had finished a couple of years of studies there, and we heard about opportunities. We heard about this guy, Wayne Knox, that was over at the laser lab that was having all kinds of fun with Gèrard. And Gèrard needed some more students and said, well, this is pretty, there's opportunities for advanced technology, the Lab for Laser Energetics, this huge Omega 24 beam laser. It's fantastic. Why don't we go over there and see what's going on? And so we did, and we met this guy. And Gèrard at that time was still wearing ties in the lab, not quite sure why. But we met this visionary for the first time. And he was telling us about all the wonderful things that we could do. We could do this and that. We're going to go this way and that way. And it was impossible not to get sucked into that. There was such energy with the whole environment and having labs to work in. And Steve Williamson was there at that time as well already. It was a no-brainer. And as we worked with Gèrard, though, what you find out that he's not only a visionary, he's somewhat of a mirage. And so the students not all students would survive working for a mirage, because what happens is that Gèrard is full of ideas. He's always looking to the future, not really worrying about the details. And he's charging forwards, and he's got, you can imagine, this trail of ducklings behind him as we were, these graduate students. And he would seed us with an idea. Go do this, go do this, go do this. And we'd say, yeah, that's a great idea. And so we run back to the lab, we do it. 2 or 3 weeks later, we go to find Gèrard to tell him about what we've done. He's like gone. He's like thinking about the next big thing. And there's no response. It's like, okay, that's really good. Yeah, go, just go back, do more. I'm thinking about something else already. But this is what it takes to be a visionary. That's what we've learned. That's what he's instilled in us. It's that type of thinking. You can't necessarily worry about the details. And you'll see as we go forwards here that when you don't worry about all the details, some funny things happen along the way. You're not quite paying attention to everything. But what we liked, and this is from a brochure from years later, but it's this thinking that this was, I'm sure you wrote this, Gèrard. It's a tool that can be applied to further the understanding of almost every conceivable scientific discipline. Okay, so this is what you have to believe, right? So there's absolutely no stopping it, right? Continuously at the leading edge of science. So this was written in, I don't know, what? Well, this was probably in the, around 90. But isn't it interesting that we can come here today and we see that that has proven to be true? So when we started, and Wayne gave you a history of the laser lab, which was a fantastic place to work, because if you ever want to inspire students, graduate students, interns, put them to work in a facility that has big science going on. Big science, big lasers, it is inspirational to students. So what had been happening? Oh, whoops. Over time, right, the spatial resolution had, this was already done for centuries. But in time, Edgerton was, for me, I still remember Doc Edgerton's work with flash tubes, and that was dramatic, and seeing baseball bats bend and crack and golf clubs and all of that. But then the mode-locked laser came. But then there was this moment, this precipitous moment here, when dye lasers started to really push the limits of timing. And that you could actually, the solid-state lasers, they did their thing, but the dye lasers were diving shorter and shorter. And in 1981, as Wayne mentioned, the colliding pulse mode-locked dye laser, that was a dye laser that kind of changed everything for us, because it was, for us at that time, we'd always been taught in the theoretical classes at the Institute that the delta function is really unique because it allows you to measure anything else with perfect accuracy. And what that dye laser did is that it gave us an optical delta function with which to work and study other things. So it was the perfect measurement tool for doing that. This is, when I think of Gèrard, you say, like, when you think of Gèrard, what do you think? This is what I think of Gèrard. That he's always breaking a barrier, and there's always some kind of stuff hanging on around the back. And this is Gèrard out here, not looking backwards, a pile of graduate students, a lot of froth, a lot of work, right near his jet exhaust. This is how it is to work for a visionary, because this is the way life goes. And to Gèrard's credit, this is from last week or something, or maybe yesterday, but when you were a student of Gèrard's, this is how Gèrard seemed to you. He was your biggest supporter. He was always rooting for you, cheering for you. He was right there for you. And that's another element of that instilling that he gave us that we've tried to pass along for the years, is that there's nothing better than to see your advisor like this. This is what he taught us. Learn what your passion is. Let it become your purpose. And it becomes your profession. It's true. The colliding pulse mode-locked laser was, as Wayne has shown as well, here it is, Wayne, it's the 27th femtosecond pulse. That was done with this crazy magic mirror. At that time, we didn't understand the effects of dispersion in the laser cavity. And it turned out that when you used an oddball mirror at the edge of its spectrum, you get these crazy dispersive characteristics that actually give you anomalous dispersion, and they correct for all of the normal dispersion inside the laser cavity, and your pulses go short. Fantastic. So this was our delta function that we worked with. And Gèrard's also, he's telling us, he said, look, the sampling scope has been around since 1960. Sampling with tunnel diodes, it's been stagnant here. And now we're working with the silicon switches and very high voltage switching that's all laser induced with these short pulses. You know, this is where we have to go. We have to break the barrier and go from the 10 picoseconds to sub-picosecond. So from my memory, it's always going sub-picosecond, sub-picosecond, sub-picosecond. That was what we were all about. And so most of you know all the history of the technical here. This was the electro-optic sampling system that we originally put together. A lot of the work that was going on there was studying high voltage switching, but this was different because we were trying to look at small signals. And when you put a small signal on an electro-optic prism and try to deflect it to see if you can actually measure it, you can't see it. You can't see it. And so there was I was a young graduate student, and I'm looking at it and say, Gèrard, you can't even see the deflection here. You want me to measure a volt? We can barely see 100 volts on this thing. And then we would put our hands in front of the beam that was driving the source, the photoconductive switch driving the signal, and you know, it moved. Did you see it move? It moved. And the deflected beam would move a little bit every time you'd put your hand in front of it. And so I thought I was really onto something here, because if I turn the signal on and off, I can actually see it moving. It turns out, when I checked with others, that the lock-in amplifier was already invented. And, and I simply had discovered mechanically that if I change a DC measurement to an AC measurement, you can see it a lot better. But that's okay, that's the naivety we approach this all with. So it enabled us, by using a lock-in amplifier and using a chopper, that's what enabled us to measure millivolt signals typically with electro-optic crystals that were only sensitive to kilovolts. These were some of the early electro-optic sampling. This is really pulling stuff out of history. Where we were shining the colliding pulse mode lock beam right through a lithium tantalate crystal. And the trick, of course, was to put it very close to a photoconductive switch. And so in this geometry, we were finally able to go sub-picosecond. So this was the first time that we went sub-picosecond. We were able to measure a rise time of around 700 femtoseconds, and Gèrard was cheering us on. This was, you know, as graduate students, you don't have a sense for what's really dramatic and what's not dramatic. So this is where the advisor plays a critical role in explaining that this is a big deal. You know, no one's done this before. And now, you know, let's push this. Let's push further and further. This is how, you know, this is how the press came out. First picosecond photo. You read this as a graduate student and said, my God, that's my work. That's our work. That was exciting. Those were exciting times. And we've broken a barrier. Again, here we are. We've broken another sound barrier. Now, there were other methods of doing electro-optic sampling that continued on in our wake, down to less than half a picosecond. There are ways of doing it with different orientations, measuring inside and outside circuits. Kevin Meyer's work and Doug Dykar's work continued on down to the point where they were generating a complete pulse that was, you know, 600 femtoseconds long, studying how cryogenic transmission lines affected the integrity of an electrical signal. It was a great time. And as 1982 rolled around, you know, we discovered that we had done some pretty interesting stuff. And it comes back to this, you know, Gèrard was, he was just a curious guy. He was passionate about what he was doing, but passionately curious. And so it's interesting, I see, you know, as I kind of prepared this talk, I see there's a lot of parallelisms between Einstein and Gèrard. And lately, even perhaps in their hairstyles. Now, I tried to find a couple of pictures that would demonstrate that, but I stopped short there. So we were sucked into this vortex. We were inspired by the passion. And Gèrard says, that's it. We're going to Europe, and we're going to now tell the world what you guys have done. Well, okay, I guess if you think that's a good idea, we'll go with you. You know, we've heard about Paris, never been there. You know, we like it. The Eiffel Tower. He says, you guys will love it. The Eiffel Tower looks like an autocorrelation trace. It's perfectly symmetric. Perfectly symmetric. And I tried to find the slide where we had the autocorrelation trace with the lattice work. I couldn't find it. So this was as close as we could get. So I said, yeah, that's it. We're off to Paris. And, you know, as we go off to Paris, you know, we're living big now. We're living large. Gèrard has taken us to the world. You know, we're packing our bags, and then I'm not sure we actually took that plane. But it felt like we did. That was the point. It felt like we took this plane. You know, and he had convinced us that we were all rock stars. So, of course, you had to travel incognito just to make sure that no one actually recognized you on the plane. You know, that would be embarrassing. Is that what it was? We arrived. We went to. It was a picosecond conference in Germany, right, in Garmisch-Partenkirchen. And so we arrived in Germany. These young upstarts. We owned the world. At least that's what our advisor told us. So you live with confidence. You live big. You live dangerously. Gèrard took us. You know, this guy's not just a technical guy. This guy took us and showed us culture. He said, Julie Andrews is out here somewhere. You will find her. Just keep looking, looking. Break the barrier. Break the barrier. Earl was searching behind a haystack. We don't know if he actually found her, but we still can't quite explain this effect here. You know, breaking new barriers. He took us to heights that we had never been. This is Zugspitze. You know, where would you see this in the United States? This is insane. But this was Europe. This is, yeah, we're golden. Look at this. They're letting us climb mountains. We're reaching the highest limits. You know, we're living dangerously. We're drinking beers at the top of it. This was an incredible time. This was it. And it's all these things that continue to inspire us along the way. You know, cheese and, you know, croissant in the French countryside. You know, beers at the base of Mont Blanc. Incredible, an incredible time. Now, you know, this was a problem. This one was a problem. Because Gèrard was building us up. He says, look, I was born in Chamonix, or I grew up in Chamonix, and it's gorgeous. It's gorgeous. Guys, you have to see Chamonix. And so, you know, in Germany, it was kind of nice. And he says, look, here's the cable car. Yeah, I think this was the cable car. Take the cable car up to the top. You're going to love the view. It's fantastic. This is where we are. The top of Mont Blanc. And interesting, huh? The mirage is nowhere to be seen. He left us at the bottom of the hill. Says, I've got to go do something else. You guys go to the top of the mountain. Check in with me later. So a broken sundial, construction going on, and a lightning storm strikes us. These guys decide to walk down. I decide to take the cable car back down because at least I'll stay dry. Halfway down, the lightning strikes the cable car, and I'm stuck. These guys have made it to the bottom already, are sitting at the bar in the bottom. And we went to the bottom. We were ordering. We had 5 beers and like 2 platters of lèvres de grenouille, which was frog lips. This is something that Wayne had picked up from Gèrard. So we were done with Germany. We were done with Paris. And he says, look, now I'm going to take you to the next. I have an apartment down in San Rafael, and I'm going to show you the Mediterranean. It's going to be a great time. And so, you know, we picked up some fast women along the way, because at his urging, he says, you know, you can't go just guys. You have to get some girls and go. Okay, so sorry about this one, Alba. As far as I know, nothing happened, but that's as far as I know. The TGV was, you know, again, it was Gèrard kind of leading us down this path of, you know, go do this fantastic thing. Take the fastest train. It's another barrier that's been broken. You break the barrier. He says, look, here are the tickets. You go. I'll see you at the station tomorrow because I've got something else to do. Okay, so where are we going to meet you? I don't know. Okay, so we're like scientists, like we're being like totally scientific about this. Let's see. How can we arrange to meet at a location where we've never been before? And okay, let's just say we're going to go to the hallway that leads to the train, and we'll go as close to the train as we possibly can without a ticket, and that's where we'll meet you. Okay? Okay. So we go there. We're winding our way through Gare de Lyon. No one speaks English. We don't know where we're going. We're taking this hallway. We can kind of, well, I think that's the train. So, okay, we're just going to sit here and wait. We wait, we wait, we wait. The tickets are saying the train leaves in 5 minutes. Gèrard is nowhere to be seen. You know, the Gare de Lyon is a bustle of activity. And it's only French. It's French everywhere. And we're like three American guys. We're like, we have no idea what's going on. And we hear on the loudspeaker, Steve Williamson, you know, I heard that once, and no, I couldn't have possibly been Steve Williamson. So we're continuing to talk, we're waiting, we're getting nervous. Steve Williamson. Steve, I think that was your name. I think that you have to go find out. Who's calling you? It's God or something. Finally, we see Gèrard coming down an escalator. There were 2 levels where we could meet that both get you to the TGV. He was on the upper level, of course, and we were at the lower level. We finally got on the train. Oh, and that's when you gave us the tickets. You gave us the tickets, and we jump on the train, and we're off. We end up in Marseille. We get off the TGV. No Gèrard. Nowhere. It's a half an hour. He's gone somewhere else. So we've got signs up. Gèrard Mourou, we're over here with big arrows. And we can't find him. We have to end up making phone calls back to Paris where we're to find Wayne. Wayne says, you know, I think Gèrard went to Saint Raphael. Where are you? Well, we're in Marseille. We're in Marseille. Marseille. I always get you and that town confused. I'm sorry. Turns out there was actually more evidence in the envelope. There were 2 sets of tickets. The second set took us from Marseille to Saint Raphael, but we didn't realize that. So, this is where we end up. Okay, young American boys, rock stars, and we're out on the Mediterranean beach. And, you know, we're just sitting around, and the girls are coming down onto the beach, and they're taking their tops off. Oh, my God, they're taking their tops off. This is really strange. Steve goes out onto the windsurfing, out onto the beach, and he's like, you know, and he sees this other girl coming with a windsurfer, and he's going to crash into her for sure. He drops his sail, and she goes by turns, topless. Merci, merci. Steve never recovered from that one. He paddled back in. Little did we know that, you know, as Gérard's fame was rising, that he would actually become the poster boy for Verizon. The first time you took that picture, I said, this is a weird one. And yes, we can hear you now. As the work continued, the sampling went faster and faster. We did external electro-optic sampling. We sampled inside circuits. There were different ways of doing things. Ended up with the cover of Physics Today. This is it. This is life with Gèrard, is pushing the limits and being encouraged to push the limits, even though you may not want to. Shock waves, breaking barriers, it all led in the same direction. There was always a breaking of a barrier. Even with the terahertz work, it was the first shock wave for terahertz. So the message continues on and on and on. And as Wayne, it always seemed impossible. I think, Dean, you mentioned there was the impossibility of the things that Gèrard was doing. But this is it. and you could do it. And we learned from that. So, merci beaucoup. Thank you. Sorry, I blew you out of the...
So I made an executive decision. We're going to have coffee now. Yes. Okay. And then we'll come back and hear Donna on the birth of CPA. So we'll have a, let's see, it's a 20-minute coffee break. So everything's going to be shifted by 20 minutes. Okay.
Yeah, why don't we put them on the whole. Thanks for not showing my one and only picture, because you guys had all the pictures. I have no pictures. Yeah, I would
I think we just go escape, and then are you on the bottom somewhere? I think you're...
You told me to go to this PowerPoint thing.
Yeah.
You said just go to there.
Yep.
And then that's me.
That's you.
Somehow, where do we put it on?
There's, let's have a show.
There we all are.
Perfect. Okay, thank you. This fabulous photo we just recreated some of was taken at Clio in 1986 when it was in San Francisco, I think, for the first time. We made some poor person we didn't know go stand in the middle of the traffic in order to get us all in and then wait for the traffic to stop. And there wasn't even a median. He was standing right in the middle of the road. The store's still there, but we haven't been able to recreate it. So our next speaker is Donna Strickland, and she arrived in Rochester from McMaster University in 1981 and started immediately working a few hours a week at the laser lab. By 1982, we were office mates. Actually, that's not quite true because there were no walls or doors involved in being office mates. We had back-to-back desks in a hallway where if you were both working, you might bump your chairs together. It's a good way to have some bonding, I guess. So. You'll likely know that after Rochester, Donna went to NRC in Canada and to Livermore Labs and to Princeton, and she's currently professor at the University of Waterloo. You probably also know that last year she was the president of the OSA, the Optical Society of America. What you may not know is that she comes from a family of certified public accountants, or CPAs. Welcome, Donna Strickland.
Okay. So I'm glad there was a break because I couldn't possibly top either of those beginning talks. And this is because I don't actually like taking pictures and I absolutely hate having my picture taken. So this really was my only picture from the time. And so luckily the two guys before me graciously did not show this picture. So I would at least have one picture of us all without our gray hair. So yes, I started in 1981. And I'm going to, oops, this is not moving forward. Oh, there we go. So first I'm going to apologize to her because as we all know, he's done this fabulous job arranging this, but I think I was a little derelict in maybe answering your emails, and I'm sorry about that. I tried to do it, but some must have skipped by, but I finally got an email from Herb saying, I really need a title for your talk. I've come up with The Birth of CPA, is that okay? And I went, what the heck, let's go with whatever you say, and I'm perfectly happy to go along with it. This is not the first time I've given a talk like that. Gèrard and I have been around this bailiwick a bit, talking about this fine invention. So the birth of CPA. So I had to think about it. So then it has to be one of my offspring. So how did it get to be that the CPA was part of my offspring? So I did meet Gèrard in 1981. And I met him because when I showed up at the Institute of Optics as a brand new grad student, some other students said, if you want to meet the people, you've got to go to donuts before the seminar. Now, I'm a Canadian, and all Canadians love our donuts, so you didn't have to say that twice. I went to donuts. And it's nice to see that Bejos Afayan is here, because I'm going to tell the story. I had my iron ring on, because I always do. This means that I graduated from a Canadian engineering school. So other Canadian engineers know the symbol. Bejos Afayan was wearing, at the time, I don't see it on anymore, it's gone. Oh, no, but you had the little, you always wore your little Canadian flag pin, too. We Canadians are very proud people. So in Canada, you have to know Bejos. For those of you who don't know him, I'm going to try to remember him. So he comes into Donuts, he sees my iron ring, and he goes, I was told there was another Canadian here, and I've been waiting to meet you, and I want to tell you all about it, and what is it you really want to do here? And I said, well, I think I really want to study lasers. Well, then you've got to come to the laser lab, and I'm going to show you the laser lab, and we're going to do it right then tomorrow, and I'll take you, and this is when I'm going to pick you up, and I'll take you there. You said exactly. I can't do the voice down here. But, okay, so I had no choice, really, okay? If anybody knows Bedros, you really have no choice once he's decided what we're going to do. So off I went to the laser lab, and he said, now, if you really want to study lasers, after he showed me the beautiful Omega system, although he's a theorist, but nevertheless, he appreciated the actual laser, and he said, but you really have to see the labs of my good friend, Gèrard Mourou. So we went into room 116. Now, that's the one that hasn't been so highlighted here yet, because there was Wayne's lab, there was Janis's lab, and there was room 116. So I got taken in. So Jim Kafka was in that lab, Earl Dooling at the time, and Todd Sizer. Ted Norris came a couple years later, a year or two later. So those three guys were in the lab. I walk in. It's a sync pump dye laser system. It's got the green flashing with the red laser. And I just walked in and went, oh my goodness, that's just like a Christmas tree. How beautiful is that? So other people have scientific reasons to do what they do. I just went with my gut and said, that just seems like so much fun. I've got to work here. So, but it was still like I was only there for 1 week, and I thought, well, I have to figure out what I'm supposed to really do as a student. So I did classes for a while, and then I thought, no, I've got time. I walked over, I phoned him up, and he said, yeah, I could use you for 10 hours a week. Okay? So that's fine. And he started me in the fall of 1981, and so let's just go to the first. So there it is. So it took from 1981 to 1985, when we finally published. That's my first baby there, CPA. But he thought, well, what can I do with her for just 10 hours a week? You probably don't even know what your first project was for, but it's coming to the next part of the slide. He said, what we need is inside Wayne's lab, there was just the front end of Wayne's was repeated on the other side of the lab, and a group of electrical engineers were working there under Chuck Stan Campiano. So he takes me in, and it's another crazy Canadian, Don Butler, and all of us Canadians were kind of a little crazy. Don Butler, John Whitaker, and Doug Dykar. So I met Doug in 1981 as well, thanks to Gèrard, and so that leads to my other two offspring. So those are my three babies, and Gèrard, of course, is directly responsible for one, indirectly responsible for the other two. So where would my life be without you, Gèrard? Really, that's what I want to say. So anyways, of course, this is back when all three of them were sweet and innocent. Okay, we won't be talking about these two that are now 18 and 20. And I'm only going to talk about this one when it was still sweet and innocent. Of course, this afternoon, we're going to hear about how it's now this big grown-up thing, producing petawatts. And I'm pretty sure at the end of the day, Gèrard's going to be telling us his dreams for the future of his baby, CPA. So I'll leave that to them, and I'll just tell you about it when it was sweet and innocent. So why is it even that I got to do it? So after I did build the box, that was my first job, to build the box for the electrical engineers for this laser so that I guess Wayne wasn't bothered by the flash lamps. I don't know. We needed a box over this other laser, and so I built that.
Street camera, what do you think?
Yeah, I know. It could have been the electromagnetic pulse. Okay. So my second job, which I don't know if Gèrard remembers this one either, there was a grad student, Ted Zura. And you had found Ted Zura this very special laser diode. I think it was going to be a mode lock 1 micron to feed in to be the oscillator of the amplifier. Great project for Ted Zura's PhD. And I don't actually remember what I was supposed to do. I don't even remember what I actually did. I do remember the result, and I actually killed that diode. Yes. So there went me going on that path for a PhD project, and I feel very bad for poor Ted Zura, because he was near the end of his PhD, and I kind of slowed it down. Anyways, he managed to keep going. So then I took my qualifiers, and then Gèrard sits me down under the, for those of us from the laser lab, he sits me down under the stairs, and he says, Donna, I have something I've been thinking about quite a long time. You see, this paper is 1973. It's now 1982. And something I would really like to study is high-order harmonic generation. Now, for those of you in the business, we're not talking about the stuff that we talk about now. We're talking about old-fashioned, seventh order had been seen, and Stephen Harris had this theoretical way of thinking he could get to the 15th order. So this this was going to be my PhD. I was going to figure out how to make cold plasmas. Then I was going to build an intense enough laser that could do this experiment. This was going to be an almighty PhD. I have to say, I'm pretty sure it was Tony Sigmund's group that finally got it to work. But several years after I graduated, they gave some kind of talk, and Jim Kafka was sitting behind me at a Clio when it was presented. I don't remember who really presented. He leaned forward, he goes, "Wasn't that supposed to be your PhD project?" And I thought, wow, isn't it good that I'm still not there trying to do it, because it would be forever. Anyway, but that was going to be it. So this is why we got started, and that I was given the project to come up with a high-intensity laser to do harmonic generation in a cold plasma. So that's fine. So here's a picture when I explained CPA to everybody else. That, although I just noticed there's only 6 photons up, so that's no good. But anyway, what we know is that we need enough photon density to have them all there at the same time, so we can do this. And as we also all know, there's only really 2 types of lasers. There was the short pulse, and so this was all the dye lasers that Gèrard had, although this was not one of them. This is just stolen from the web. His were much more sophisticated and beautiful, because his were always beautiful. And so we had that, and of course, Earl and Jim were busy trying to make it as energetic as possible, but as we know, dye can only be so energetic. I don't know, what is this laser? Chris is here. Is this like NIF now or something? I don't know where I stole this one, but this was not one of our lasers, okay? Neither of these were. But what we had was Wayne's, sort of the most energetic laser that he had at the time, I think, was Wayne's, but it was 30 picoseconds. Is that right? 30 picoseconds. And then we had the amplified dye, but we didn't have everything all together, but Gèrard was thinking about it. But in the meantime, when I needed something, the first thing that we tried was this. We had Wayne's laser. So oops, where's my? So Wayne showed you, maybe what it really looked like, but this is schematic, umpteen of these things. I can't believe I had 6 CS2 cells, but I remember the smell. Everybody use CS2? I spent a year of my life doing this. Okay, so we tried to do pulse compression in CS2. All right, and so we took Wayne's 5 millijoule, 30 picosecond, I think I'm remembering right, and we focused it through several cells. You would make a lot of bandwidth, you would compress it, and then what did we get? Not very much, because here we were still with the same sort of pulse duration that we started with, okay? And so, of course, we realized along with everybody else that the problem with self-phase modulation of a whole beam is that every power point does something a little bit different. So if we put a pinhole and only took the center portion of the beam, then we did indeed get the nice short pulse we were looking for, but we'd thrown away all that beautiful energy, so we probably had less than what they had in 116. So that didn't work. So now my PhD is moving along slowly but surely, and we go to Clio, but not the one not in San Francisco, must be the year before. And here's, Jim Kafka is now at Spectrophysics. Is your name there? Yes, there it is. So I picked that one. And they reported on pulse compression in fibers. So of course this is the right way to do it, because the beautiful thing about fibers is that it's a plane wave and all the power is the same, and so the whole beam can have self-phase modulation, and so we can do it. And so Gèrard was ready. He had all the parts now for his great idea. And there it is. Chirp pulse amplification, we all know it. Don't really need to explain it, but here it is. You take a short pulse, make it a long pulse, amplify it up, make it a short, really big pulse. So this is the idea that Gèrard had, and we now had all the components. Because although we had short pulse lasers, they were all the dye lasers. We had Wayne's amplifier, but it really wasn't as broad as we wanted. But of course, we were sitting there beside a great big glass laser system, the Omega, so it's not like we didn't know that glass would be a good alternative, okay? But of course, those are 2 different wavelengths. But once we had the pulse compression in the fiber working at 1 micron, we had it all. So what we didn't have, I guess, is money for the project, okay? Now as a professor, I can really appreciate that. But at the time, I think I was missing that piece. But anyway, Gèrard being Gèrard was pretty good at it. So Gèrard phoned up, I think he phoned Quantel, I don't know, somebody in France, because he always said somebody in France. So we got a really old Quantel laser head to be the regenerative amplifier. And he phoned up somebody at Corning, and they just explained this incredible idea and said what we need is a lot of fiber, single mode for 1 micron. Okay. I think Gèrard had forgotten the story until I told him a few years ago. Now I've heard him tell the story, so I should never have told him the story. But or reminded him. So let me come to it. There I am. and so young. This is when we had to have our goggles on in pictures because to show we're safe, but I'm pretty sure the glasses are actually out. So, right? So we're safe, but not really. The other thing is whoever took this photograph of me insisted that I touch the mount, and I said no. I'll explain why I would not touch that mount. So there I am just holding the fiber. So he phoned and he begged and he explained the beautifulness of this whole project, and Corning bought it. And Corning sent us 2.5 kilometers of fiber. Because we just didn't want to do pulse compression. We didn't need just the 300 meters or whatever JK had used for it in his project, because we knew we wanted to stretch so much we could amplify up. So we wanted as much fiber as we could get. And Gèrard wanted as much fiber as he could get. And he got 2.5 kilometers of fiber. Now when the spool came, I guess most people that order 2.5 kilometers of fiber from Corning really want the fiber to go from A to B, and that must be 2.5 kilometers apart. Because they sent it with just the one end showing. The other end, not there. So, I know. It's a problem. So I had 2.5 kilometers on a spool that I had to, by hand, unspool onto another spool. So I did that for, well, I'm sure quite some long day, and put the fiber in and looked for put the light in, looked for it at the other end. Nothing came out. So I took my IR viewer and I looked at the spool, and sure enough, the light was coming out in the middle of the spool. So I had to unwind the fiber until I found where the light was coming out. And wouldn't you know, I had nicked it and broke it at almost in the middle. So now we were down to, the longest piece was 1.4 kilometers, and we didn't have our own splicer. This was our first fiber project, was it not? So that's it. We had to deal with 1.4 and hope for the best. Okay, so now we just needed an oscillator. And we didn't have one because money was not there for this project. But what we did have is 116, which I was still waiting to work in there because that is the one that had the beautiful red and green Christmas tree laser. Mine was colorless. And it was a sync pump system. So Todd Sizer had a mode-locked YAG that he frequency doubled to pump the dye. But of course, frequency doubling 10%, so 90% of that light just sitting around doing nothing. Can't have that. So this is it. So by now, this is Earl's system. It was Jim's system, but now this is Earl's system. He's over there building his kilohertz amplifier. This is Todd Sizer's table. They found me a little bit of room. Okay, they squeezed me into this very busy lab, and we put the fiber here, and that's the mount, and I put the light in here. But of course, there was no room for the CPA actual laser amplifier in this room because there was room for my spool and fiber mount. That's what there was. So we actually built it diagonal, for those of you who've been to Rochester Laser Lab, diagonal into a lab across the foyer. So we had to get the fiber, probably illegally, up and over and down into the other lab. And I'm afraid of heights, and I'm claustrophobic, so there was no way I was doing that. But luckily, Shou Xiaoxian, who had nothing to do with this project, but she was the tiniest one in our group, and so we asked her if she would be willing to climb up into the ceiling, carrying the BNC cable and the fiber, and crawl through pretty much the whole length, the width of the laser lab, over to the other one and bring it down. So she did it, bless her heart, and the fiber came out where it needed to come, but really what a pain. I think originally we didn't even put the cable. I think originally I had to do it by phone, and somebody watched a power meter, and then we realized, so could you not go again with the BNC cable, so I would have at least my own detector. So that's how the CPA started. The oscillator was in one room, and then we went ahead and built the amplifier. So that's what I'm going to thank to Marcel Bouvier. I think if we were back in the days of, or if we'd had our cell phones like everybody seems to now, I would have had a picture of this, because this old Quantel laser that I had to use almost never worked. And luckily, Gèrard had hired Marcel Bouvier, also from France. All the good people come from France. And or Canada, it's true. So we had this thing that never seemed to work. So Marcel spent a heck of a lot of time in the lab with me until finally Doug actually took some masking tape, and over the QUANT he put MARC, and we left the EL, and from then on the laser was just the Marcel. Because he had put more time into it than any Quantel engineer, I'm pretty sure. So thank you very much. So he kept the lamps firing and kept going. Doug wants me to tell the other Marcel Bouvier story, and so I'm going to, because he's here. And this is now Patrick Main, who I just saw. Yeah, he's here too. By now we had 3 stages, so this is not the baby CPA. This was the next CPA. But there was 2 more borrowed old Quantel lasers. And I think, obviously, nobody else wanted these lasers. That's why we got them. And it was 4 lamps around, and it wasn't working. Where is Marcel? Does he remember this? Do you remember this happening to you, Marcel? And so he was standing, and the rest of us were down at that end of the lab, and he was there with this laser. He goes, that one's working. Do you remember this, Marcel? That one's working. That one's working. Poof! And the electricity came out and zapped him. He goes, that's the one not working. Okay. So Marcel had to fix that one too. Anyway, okay, that's a Marcel Bouvier story, not a Gèrard Mourou story, but it's all what happened in the lab. So a lot of people helped me get that thing going, and it took about a year, and then we compressed it, and of course, that's the story. But when we compressed it, of course, there was no way to measure it. So now I thought I had a short pulse, intense laser, and I had no way to measure it, but luckily Steve Williamson, who we've mentioned many times here so far, oh, there he is, he by now had his Hamamatsu street camera on a push cart. Like, he had given up on the lasers. He said, you guys have the lasers, I've got my street camera on a push cart, I can go anywhere. And so I went to him and said, can you bring it in to my, and he was perfectly wonderful, and he came in and we spent one whole evening together getting this result. So I want to say that when I wrote the first CPA paper, there were 3 authors on the paper. I put 3 authors on the paper. One of them was Steve Williamson. But Steve Williamson took his name off this paper. So that's why we're down to just 2 authors. But for Steve, you should have stayed on this. Anyway, so this is a street camera. This showed the resolution. And so it had 2 picoseconds resolution, so we could claim that we were down to the 2 picoseconds. So that was the laser. It was done. So we're ready to publish it. So it came out. So we sent it off July 1985. Now, at that time, early that fall, Réal Vallée had come down from French Canada, and he was wanting to be a postdoc with Gèrard. And he really impressed me with how well he had rehearsed or practiced or got ready for this interview. He just knew everything. He was just there. And we were showing him the CPA laser, and he said, oh, well, I just saw your paper on this. And Gèrard and I looked at each other, and we said, well, they didn't even tell us it was accepted. How could you be already seeing this paper? So that was funny. So he goes, oh, well, I brought a copy with me. I thought, oh, well, that's because you're really well prepared for this interview. But he said, I don't get the figure. So then Gèrard and I are looking at each other. I'm going, Réal, you were doing so well. Because I've already shown you the baby. Yeah, I've already shown it to you, right? What is it? There's a fiber. There's an oscillator. There's a fiber stretching it. You amplify it. You compress it. I mean, it doesn't take a Rhodes Scholar. That's the beautiful thing about CPA. Once the idea is there, it's a pretty simple idea. So I'm thinking, how can you want to work for Gèrard and you can't figure out this simple little picture? So he's got it out and he shows us. Now I want you to imagine when you see this picture what Gèrard's response was. There it is. That was the picture that was in the original CPA. So the laser picture that I showed you was not in it. Okay, my very first publication ever. 1985. It came out in October, so I have to say Optus Communications was fast, fast, fast. We said it in July, and they put it out in October. I don't even know where they found that figure from. Okay? I brought home a copy to my sister, the mechanical engineer, thinking, I think you get this picture better than I get this picture. Anyway, huh? So can you imagine Gèrard? That was the end of the interview with Réal. Okay, so Gèrard, I think, just went red. Hair on end. And I don't know, because I'm sure you phoned right away, but unless it was early in the morning, I don't know how you phoned Europe. But anyways, maybe you have like the names of all the phone numbers of all editors, you phoned them at home. I don't know, but he was on the phone saying, you're not giving me any old stinking erratum. This is an important paper, and you're going to redo this whole paper again with the proper figure. And he didn't get off the phone until they said, yes, Gèrard, of course, Gèrard. So it did come out again. So this one still gets published a bit, or still gets cited a bit. So out of all the citations of yours, a few of these are still this one. Although why people send you to a paper that has this in it, I don't know. But anyway, that was it. Okay, so just a few interesting tidbits of when we got the CPA laser to work. It did lead to a New York Times article. And so then there was 2 students at the University of Rochester very upset with us, very upset. One was a political science student, so you have to forgive him, you know, because he's not going to really know science. But the other one was a mechanical engineering student, should have known much better. And he said, it says you want to do atomic physics with this laser. We know, and I'm sorry about this, Sasha, we want to blow up, you want to blow up Russian missiles. That's what we know you're building this laser for. And I'm going, are you kidding? So we invited the 2 students over. We bought a little toy missile, and we were going to like shoot it to show we couldn't even knock it over, let alone blow it up, okay? So that all we could do was pit it. And so we brought them over, and of course the laser didn't even work that day, because most of the time the laser never worked. So we showed them nothing, but at least we convinced them that no, it was going to be this great and exciting laser, but it was not ever going to blow up a Russian missile, or anybody's missile for that matter. All right, so then the other one was Gèrard got a letter from a man in the prison. What's that prison? In Batavia. There's a prison near. And he had gotten himself a laser kit from, I don't know where one gets laser kits from, but he had built himself a little laser, and he had read this thing about CPA, and so he wanted to build an even bigger laser. Could he get a CPA kit? So we had visions of this guy in jail, like digging himself out with a CPA laser. All right. And then finally, some business magazine, I don't remember which one it is, they said, we've decided you're one of the top 10 inventions of 1987, which of course was weird, because of course it was invented 2 years before that. But anyway, they had heard about it. And so they brought a photographer. Okay, so I think, Patrick, you were more involved with this than me. They put this photographer, and they went back, and they went, these pictures aren't very pretty, right? Because I always said, the pretty one was 1/16. If that's what they wanted, I had a colorless laser. So we frequency doubled it for them, and they went, no, not really pretty. And so then I think you actually came, was it you that came up with the idea of actually burning paper or burning wood? I mean, we tried. Okay, whatever, we did our best. We tried to make it as pretty as possible, but I went and got that magazine, and we were not one of the 10 top inventions after all, because obviously we just weren't pretty enough. So there you go. So we're back to the Rochester Big and Tall. That's my only picture with me and Gèrard at the time, but Gèrard has since sent me this picture from, I think, 2 years ago. So I've told a lot of people a lot of times, Gèrard, I got to do one of the world's best PhDs, and it's thanks to you. So thank you and happy birthday.
Okay, we turn now to the Michigan Days, and Steve Yalosov is going to chair the session.
All right, well, my name's Steve Yalosov, and I'm not an optics person. I'm a material scientist, and I can't possibly follow what Jim did, because I didn't even know these guys. In fact, the first time I ever heard of Gèrard Mourou was when I went to go look for a friend of mine at Bell Labs, and I ran into Doug Dykar sitting in his office, and I'm like, who are you? And but I heard about Gèrard Mourou, and then when I finally got to Michigan, I met Gèrard Mourou, where he came up and told me that I have to use his lasers, and I'm going like, what for? And he said, because they're beautiful. He said, you just have to use them. And I said, well, you know, materials, you know, maybe the attempt frequency for a hop in a crystal is femtoseconds, but nothing else was. And so I ignored him, but he kept coming. And so then I started using them, and it's amazing. It's amazing what a 150 femtosecond pulse can do to a material, sometimes as long as a minute or even 20 minutes later. And so I've built a pretty successful program on Gérard's beautiful laser, so thank you, Gèrard. But not knowing any optics, Gèrard used to tell me that, he said, remember, there's only one good use of the English measuring system. And I'm going like, what's that? And he said, you know, light travels 1 foot in a nanosecond. And recently I was talking to Ron Gilgenbach, who's the chairman of nuclear engineering here at Michigan, and he knows Gèrard very well. And we were talking about this guy that CNN hired to be on the television when the Fukushima accident happened. The guy was not a scientist. He was a nuclear security expert from MIT. And this caused massive problems in nuclear engineering programs around the country, because they were calling CNN and saying, would you get that guy off of there? We'll give you National Academy members. He doesn't know anything about it. And CNN said, no, we're happy. We like this guy. And then Ron was telling me that about a month ago, or was it 6 months ago, because it's been going for a long time, they had this same guy talking about the Malaysian airline disaster, because of course he was a nuclear security analyst. And he said something that made me think this has got to be Gérard's next barrier he's going to break. Because he said that this Malaysian airplane, this aircraft, what are they, 60 feet tall? If it hit the water, it would sink in 1 nanosecond. So Gèrard, your next barrier. Anyway, I'm very happy to introduce our first speaker, who I heard about from Gèrard before I met him. And, you know, when I heard about Steve Williamson, you know, I thought this guy was God, because Gèrard explained to me that, you know, as an undergraduate, Steve Williamson did he did pump probe diffraction, right? Picosecond diffraction, and it only took him 1 week to build the whole piece of equipment and make it work. And that was like the longest time it took him to do any of the stuff he did. A street camera, 2 hours. But Gèrard never exaggerates. But there's something really important there, and that's that Gèrard invited Steve into his lab and also Wayne into his lab when they were undergraduates. And he treated them like graduate students, and he expected as much of them as graduate students. And I've had the privilege to work with Gèrard for the last 6 years now on an undergraduate research program that we're running in France, Optics in the City of Light, a good title like Gèrard's good at. And I think his dedication to undergraduate research is really legendary. It was before his time. And I'm running a symposium at the Materials Research Society on undergraduate research, but I owe a lot of that to Gèrard and how inspiring his experience has been with Wayne and with Steve. Were there other undergraduates also? A couple others.
Compared to graduate students, we were cheap too.
That's right. But he always told me that a great